Thanks very much, Mike, and thank you very much for inviting me to this inaugural event. I'm going to be talking about intelligent mistakes in test automation. Now, you might think that sounds like an oxymoron. And yes, it sort of does. Now, when I mean test automation, I'm in the software world. I'm not in the hardware or embedded world. So when I'm talking about test automation, I'm talking about the automation of the tests for software, usually at a system level. So why intelligent mistakes? What do we mean by intelligence? I looked it up in the dictionary. A mistake is something which is an action resulting from defective judgment. You do something wrong, deficient knowledge or carelessness. But intelligent is exercising good judgment. So in a sense, yes, this is an oxymoron. And an intelligent mistake is where you have an action based on a faulty premise with the best of intentions, but with some adverse consequences. By the way, this little box on the side is showing up on the screen. That's better. I feel better already, don't you? No, this isn't working.
Sorry, to keep back the, yeah, that should work.
Okay. So I'm going to look at 5 of these intelligent mistakes. And the first one is automation should find lots of bugs. Now, this sounds very sensible, doesn't it? Surely this is what automation is to do. I mean, it seems like we're going to be automating tests, and tests are supposed to be finding bugs. So if we automate them, they're going to be much faster and more efficient and more thorough. So they should find lots more bugs and find them more quickly, right? Well, it sounds sensible. However, there are some problems. What tests are we actually automating? And what does automation actually give us? Now, comparing regression tests and exploratory testing, which type of testing would you say would find more bugs? Exploratory, no doubt about that, right? That's where, if you want to find bugs, do exploratory testing. That is the most effective way to find lots of bugs and quickly. Now, what do most people automate? Regression testing. Regression testing by its nature doesn't find many bugs because you're running tests that have already run before, and the last time they ran, they passed. So how likely is something to do something different this time? Not very. It's good if we catch it when it did. So we're automating something which doesn't find many bugs, and we're expecting it to find lots of bugs. This doesn't make a lot of sense. It's not automation that finds bugs. It's tests that find bugs. Automation is a mechanism for running a test. The bug-finding ability of an individual test is the same whether that test is run by a person or by a computer program in general. Now, this can be a very dangerous objective, especially if you're automating your regression tests. At one of the recent conferences in the States, at lunchtime, I sat down next to a guy who turned out to be a fairly senior manager, and I was asking about whether they did test automation. Oh, yes, he said. They've got a team of 3 or 4 people. They've been automating regression tests for about 3 years now. They tell me they've got lots of tests automated and all that, but I'm thinking of canning the whole effort, just dispensing with it all. Why? It's not finding many bugs. Well, in the end, I tracked him down a bit later on, and he did actually dispense with regression automation, but it was actually for other reasons, and they've gone on to do some more better automation. But if you have as your goal of automation to find bugs, and you're automating regression tests, you may be setting yourself up for failure. Now, in the recent new book about experiences of test automation, there was only one chapter that actually quantified how many bugs were found by the automation. And the percentage of bugs found, fixed verification, by the way, found about 8%, and the manual scripted testing found about 24%. So of the remaining 2 categories, the automated regression tests and exploratory testing, do you think it was maybe about equally distributed between those 2? No, I think I'm going to get some uncannily accurate audiences from you because you've got it printed in your notes, haven't you? The exploratory found about 60%, and the automated tests actually found less than 10% of the bugs. Did that mean it wasn't worthwhile? Not at all. What it gave them was confidence that there weren't regression bugs there, and it did find a few bugs, which was very useful. Now, if you notice on the front of your books, it says the aim of this conference is about effectiveness and efficiency. That's great. because the two are different. When we talk about efficiency, we're talking about have we got slow testing or fast testing? Let's automate our tests, then we'll have fast testing. Obviously, that will be better, right? Well, that's efficiency. But it's actually more important to think about effectiveness of your tests. You can have poor slow testing, or you could have poor fast testing. What you really want to do is to have good testing, and that's more important than fast testing. Unfortunately, most people maybe start out down there with poor quality slow testing, and most people move to the right and automate what they've got. And that is not the best thing to do. You're much better off moving up first and getting better quality tests before you automate them. If your current testing process is in chaos, automating chaos just gives you faster chaos. You're much better improving your testing and then thinking about making it more efficient. So this is where you really get the greatest benefit. Now, having said that, automated tests, finding more bugs is not a good objective for regression testing. There are some kinds of testing, automated testing, where you do find lots of bugs. I got into an argument with somebody about this, so this slide is a result of that. Whenever the first time a test is run is in its automated form, then it's most likely to find a bug. The bug finding potential of any test is at its highest the first time it's run, which is why regression tests don't find many bugs. So things like test-driven design in Agile, or business-level test-driven design, model-based testing, where the tests are generated. Anytime you have automated generation of tests, monkey testing, or there's a thing called exploratory test automation, which is not the automation of exploratory testing. It's a way of automated testing which is exploratory in nature. Harry Robinson, I went to a tutorial from him about that. Doug Hoffman, the Oracle guy, has done a lot of work in that as well. If you have lots of random input, and if you have automated heuristic oracles, which tell you if you're in the right ballpark, you can do a lot of automated testing that way. And then the first time a test is run, we'll find a bug. When you're doing keyword-driven testing, where the users are writing the tests into a spreadsheet, and then the first time that test is run is from that spreadsheet in its automated form. What about supposing you've got lots of automated tests so that the testers are now free to do better testing and more exploratory testing, and now the tests that we're running, we can test a lot more of the system than we could before. So we're finding bugs in parts of the system we never had time to test before. Doesn't that mean that the automation is finding more bugs? Well, no, actually, this is an indirect result. It's the fact that you're finding more bugs is because you're running more tests. If you got 200 people in overnight to run those tests manually, then you would find those bugs. It's not the fact that they're automated, although that does enable you to run more tests. I think this is an important distinction, precisely because it's easy to go wrong with it. So that's the first one. The second one, automation comes out of a box. Well, these days it's not a box anymore, is it? It's just a download. But you buy a solution, right? Seems very sensible. Automation is going to give us great benefits. You've heard all these success stories. Spending a lot on the tool will guarantee great benefits, right? And all we need to do is to get the right tool. I was doing a tutorial a couple of weeks ago at Star West in California. And one of the guys on the tutorial said, "What's the best tool?" Interesting question. There's this view that there must be the perfect tool out there. Now, there are technical issues with this, and there are also management issues. Now, if you're doing test automation, which I mean the automation of the execution of system-level tests, the testware architecture is critical for success. The reason why most people, when they automate system-level tests, end up putting the tools back on the shelf, I don't know where they go if they've been downloaded. You just stuff them back down the line somewhere. You just abandon them, don't we? The most frequent cause of automation being abandoned is high maintenance cost, and the most frequent cause of high maintenance cost is a poor testware architecture. Now, what do I mean by this? Well, there are two layers of abstraction which are critical for good test automation. If we have our testers up here and the test execution tool down here that runs the scripts. Everything in between is your testware architecture. And if you do nothing, you're effectively having a null testware architecture. Your testers are connected directly to the tool and writing scripts directly in that tool's language. You have no testware architecture. That's one way to guarantee high maintenance, by the way. But there are two aspects of the layers of abstraction here. The first one is the interface between your tests and the tool itself. That wants to be kept separate. You want to make those independent of each other. You want to write your testware in such a way that the tool-specific scripts are minimized. You want to have you put all your effort into writing automated tests, not into writing automated scripts, because the scripts are tied to a tool. Yes, they are scripts at a higher level as well, or they could be, but the more closely tied you are to your tool, the more problems you're going to have. You want your automated tests to be able to survive more than one release of your software, right? You don't want it to fall apart as soon as the software changes. Yet this often happens when the automation is very brittle because it's too close to the tool. You also want your automation to survive more than one release of your tool. You might think, oh, our tool is perfectly okay now, but then the tool vendors might change it on you. Or you might have to go to a different tool because your product has moved in one direction and the tool has moved in another. The more separation you have at this level, and it's good programming practice, it's basically having structured scripts, just putting into practice things that developers have known for a long time, applied to the testware. So for a long life for your automated tests, you want to have that layer of abstraction. And then the other layer is between the tests themselves and the testers, especially if you have people who want to write and run automated tests, but who do not want to write scripts, write in a scripting language. If you have people from the business background who are really great testers, they should be able to write and run automated tests. It should be easier to write a new automated test than to run that test manually. But it takes effort to get there. You have to build the right testware architecture in order to enable that. So if you're writing things with high-level keywords, you're effectively using a domain-specific test language. The tests are written in the language of the people testing that domain. So if it's an insurance product, the test language would be things about policies and claimants and things like that. If it's a mobile phone, the test language would be contacts and calls and put on hold and things like that. Whatever the language of, if you just hear two testers talking to each other, oh, I'm going to test this and I'm going to put this input, I'm going to do this, that's the language of the testers. That should be something which can be automatically translated into an automated test without the testers having to know the detail. Somebody has to know the detail, but not all the testers, and especially not the business level testers. So and of course, if you make it easy to use, more people will use it. So you get more benefit from the automation. The easy way out, by the way, is just to use the tool's architecture. Well, the tool tells me where to put everything, so I'll just do that. Yeah, tool vendors will be very happy. I'm sorry, there are tool vendors here, and I don't mean to insult you unduly, but I do encourage people to keep separation from the specifics of whatever tool you're using. By the way, if you want a bit more about testware architecture, there's a good book I can recommend, especially Chapter 6. And it's not about the tool. You know, what's the right tool? What's the best tool? When this guy asked me in the tutorial, I said to him, what's the best car? So think to yourself, if money were no object, picture so you've won the lottery or you've won a prize. You can have any car you want. Money no object. Which car are you thinking of right now? Maybe some of you are thinking of something like this. Yeah, would you like one of them? Yeah. My son-in-law, my new son-in-law, who got married on the 1st of June, my son-in-law is a software tester, by the way. You can't beat that, can you? But he likes classic cars. So maybe for him, that would be the best car if money were no object. But if you happen to have 4 kids and 3 dogs, then maybe something like this would be the best car. So what's the best car? Same question, what's the best tool? There are things which will be suitable for you. And what we're talking about here, we do have a cost associated with a tool, and we want to get some benefits. So we might have a high, we don't pay very much, but we don't get very much value. Or we might pay a lot and not get very much value. Or we might pay a lot and get really good benefits. Or we might get good benefits and not pay a lot. So where would you like to be? Have you got commercial tools, open source tools? There's sort of a perception that the commercial tools are on this side, on the expensive side. But you get good benefits. That's one perception. And the open source tools, oh yeah, they're not worth anything because they don't cost anything, is the perception. However, it's not necessarily like that. I've seen increasingly recently where the expensive commercial tools are not giving the sorts of benefits that people are hoping for. And I also see increasingly people getting very good benefits with open source tools. Whether, what this means for the future, I don't know. There are still niche areas where the commercial tools have a place to play, but the open source community is growing. And you do have to put some effort in order to get success in automation. So maybe we should call this moderate cost on the open source tool side. It also takes time and effort to succeed. It doesn't come instantaneously. What comes out of the box is not a fully fledged solution. And you need to have management expectations set realistically so that you can actually do what needs to be done to produce good automation. High-level managers need to understand what automation can do and can't do. Building good automation is not something which happens instantaneously. It's a learning process. And there are people issues. Yes, they're software tools, but the tools are built by people. The tools are used by people. And if you get the people issues wrong, that can seriously derail an automation effort as well. It's a difference between automated tests and automated testing. If we have manual processes in the light blue and the automated process in the dark blue. And here on the left we have automated tests, right? This is what comes out of the box. So we're doing some manual setup of identifying the test cases to run, setting up the environment, repeating for each test case, set up prerequisites. Now we have execute and compare results. That's what the tool does for us. Then we're going to log the results, analyze the result, report defects, clear up after the test case, repeat that loop, clear up the test environment, and summarize results. Yes, we have automated tests, but it's embedded in a manual process. What you really want to have is automated testing, not just some automated tests. And in order to do that, you need to do a lot more than just what comes out of the box. You have to build stuff around the box. You need to automate as much as you can of all these other activities. Setting up the test environment, loading data, doing the repeating for each test case, setting up the data, comparing results, logging results, clearing up afterwards. Yes, we still need to analyze the failures and report defects. But here we have much more of an automated process with automation built in and automating a lot more than just the tests. Let's automate all of our manual tests. What a good idea. Seems very sensible. We've got lots of tests being done manually, and automation would obviously be much quicker. So we can be completely automated, and therefore we don't have any need for testers, right? Have you heard this argument? Yes? Ooh, a bit frightening, isn't it? There are some problems here. First of all, what tests are you automating, and then what are you missing if you're only automating your manual tests? So here are our manual tests, and here are our automated tests, and these are the ones that we've automated so far, a certain percentage. Should we be trying to move the circles together to make all of the manual tests automated? I don't think so. There will always be some tests which are better run manually. Tests that are not automated yet, tests which should not be automated. Do you know when you go on a website and you have to type in these wavy letters? It's called CAPTCHA. The purpose of CAPTCHA is to make sure that it's a human being doing the entering and not a computer, right? So if you can automate that test, your software has failed already. Well, I know there are ways to get around it, but that's an example of something which actually shouldn't be able to be automated, because if it was, it won't be working. But there are other things as well. There are tests that are not worth spending the time automating. Simon Mills, who was supposed to come today but then had to pull out, tells a story in the book of one of his automators who was really keen on automating. I want to automate. He found a certain test and he decided he wanted to automate it. He spent a day, but he hadn't quite got it right. He spent another day, spent a week. No, it's not quite automated yet. Spent another week, 10 days, and still hadn't quite got it to work. This test only took half an hour to run manually and was only needed once a quarter. That was not a good test to try and automate, especially since it was very difficult to automate. You want to concentrate on automating the things that give you the low-hanging fruit, giving quick feedback. Concentrate on automating the things that people don't like to do or do badly. Let computers do what they do best and let people do what they do best. Now, on the other side, there are things here where with automation, you can do things that would not be possible or practical to do with manual testing. If you're testing manually, you're sitting there and looking at what's coming up on your screen, and you say, well, that looks about right. Oh, yeah, that looks about right. You're seeing things, but do you know whether those GUI objects are in the right state? With an automated test, you can check things like that quite easily, and other things. And exploratory test automation that I mentioned before. That's a way of testing which is not possible to do manually. It's only possible to do it in an automated way. So if you think of automating only your manual tests, that's not going to give you good results from automation either. Harry Robinson talks about horseless carriage testing, where if you just automate what a carriage used to be, he said the early motor cars actually had a place on the side of the car, a little cylinder, and people say, well, what's that for? That's where you put the whip for the horses. Okay? It was a horseless carriage, but the carriage had been transformed almost literally into something new, but that wasn't the best way to do it. Now, what about this? Okay, we can reduce the number of testers once we have the tool. Popular with high-level managers, I find. The question to ask is, what are your testers really like? What do they do when they're testing? Do they follow a script blindly, word for word, no matter what happens, and just mechanically reproduce everything as it appears without ever putting their brains in gear? In that case, your testers might be mindless morons, in which case maybe they could be replaced by a tool. But if your testers are people who, as they're running through a script, are thinking, they're saying, I know that's what the expected result says, but I know that's wrong, and what about this, and what about that? Then you have intelligent investigators. Intelligent investigators are not replaced by tools. The tools do the mindless stuff, and they do it very well. But a tool will never say, oh, hey, I wonder what happens if we do this. It just doesn't compute, right? It's just a tool. It's just a computer program. In fact, if you're going to automate tests, you don't need fewer testers. You usually end up with more because you need more skills. Because writing scripts in the testing tool does involve skills. What should happen is the automation should free the testers to do better testing, to do more exploratory testing, to be more effective, to think up more tests, to generate more automated tests. That way they will find more bugs because they are now doing more tests because the automation is doing the drudgery tests. They can do the creative tests. Tools don't replace testers. They support them. Return on investment. A lot of times people say, oh, we have to make sure we've got return on investment. We have to prove we're going to get return on investment before we'll invest in the tools. And it sounds very sensible. We're spending time and maybe lots of money on the tools, so obviously we don't want to spend money unless we're sure we're going to get some payback from it. And that is indeed a sensible approach. And a watertight business case will convince the managers to invest in automation. There are problems. Return on investment is not the whole story. People, by the way, are not convinced by numbers. I sometimes think the more people ask for numbers, the more they're just resisting. They ask for more and more numbers and a more and more watertight business case because they just don't want to do it. Decisions are not made on rational basis. Decisions are made on emotional basis. People are irrational. I'm sorry if this comes as a shock to you. We're technical people, right? And a lot of times we focus so much on the technical bits, we forget we're human beings as well. And calculating return on investment for automation is difficult and can be dangerous. Now, I've been interested in trying to show a reasonably simple way to calculate ROI for automation for a number of years. I even put together a spreadsheet that shows a simple way of doing that. But in the last couple of years, I've become aware that this actually can be rather dangerous, and I'll explain why. But first, I want to say, how many of you here have these test execution automation tools? Maybe half. How many of you get good return on investment from them? Oh, not very many, about 5. That's interesting. I like to ask people, what return on investment do you get from the test automation? And I typically get answers like this. Well, the tests are run more often. You do this? Yeah. Tests take less time to run. Takes less human effort to run the tests. We can test or cover more of the system. We can run the equivalent of days or weeks of tests in just a few hours, or minutes even. And faster time to market, that phrase that makes high-level managers go weak at the knees. So, I mean, is this good return on investment? What do you think? Well, I've got some good news and some bad news. The good news is these are all great things. They're great to have. They are benefits of automation. But the bad news is it's not return on investment. These are benefits. They're great benefits. They're good benefits. Return on investment is a calculation. It's a number, usually expressed as a percentage. Benefit minus cost divided by cost. So if you are asked to show return on investment for a tool, you need to investigate what are the costs. That's usually fairly straightforward. Either if you're purchasing a tool, there's a purchase cost or license costs. There might be training costs. You might want to have a ramp-up costs. So the costs are usually fairly easy to pin down. People's time will be involved, but you can easily translate that into money by just multiplying by a loaded salary factor. But what about these benefits now? How can we quantify the benefits to put into the equation with the costs? Tests are run more often. What's that worth? Can you put a pounds? How many pounds is it worth to run tests more often? I haven't found a way to do that. If you have, I'd be interested to hear from you, but I think that's hard. And what about tests take less time to run? Again, that's hard to put a number on. What about the third one? It takes less human effort. Ah, bingo. Yes, we can quantify that because human effort we can quantify. And if it takes 2 testers to run the tests that it used to take 10 testers, yes, we can quantify that. Okay, so we've got one there. We can cover more of the system. Difficult to quantify. These other 2, faster time to market. Oh, if you have a marketing department, they might be able to give you a number for faster time to market. Yes, if we can get in 2 weeks early, that will be worth so many pounds in our market share. So you might be able to get something for that. But again, it's difficult, isn't it? The problem is the one thing which is easy to quantify is the people time, less human effort. So return on investment tends to focus on that and to concentrate on that. But that's not the whole story. And that's where it goes wrong. That's where it can be dangerous. It may give the impression that you can now dispense with all these people. Oh, I've blogged about this as well, by the way. I love the quote from Yoram Mizrachi. He says, automation is an enabler for success, not a cost reduction tool. And I think that's becoming, this is in the mobile area, but I think that's becoming increasingly true. And many people, when we wrote the book of experiences of automation, we pressed people quite hard, saying, show us what return on investment you have. And we had some stunning examples. I think the best one was 900%. And another one said, because we have freed up 18 testers, we say, you didn't have to hire 18 testers this month because we've been able to use the ones we already have. They never let any testers go. They just got much better testing out of the ones they had. But one of the key things, but many of the people contributing to the book weren't able or didn't show return on investment as we wanted them to, because we wanted this quantified. The key thing where they were successful is that they made the benefits visible. And that's the important thing. Even if you only have a few benefits, even if you're only starting off, make those benefits visible to justify carrying on. And just an example, and this comes from that spreadsheet, which I'll email you if you want a copy. These are hypothetical examples. The execution speed of the tests, they now run 14 times faster. The tests are run 5 times more often. The data variety, we have 4 times more types of data that we can test, or more coverage of the system. And the tester work takes 12 times less effort to run these particular tests than they did when they were run manually. Notice this is the most dramatic one, but it's not the only one. And the last one, testing tools are testers' tools. Seems like a good idea, seems very sensible. Testers do testing. Testing tools help testing. So therefore, the tools will make them better testers because they'll be able to run more tests and faster. So obviously the tools are for the testers. Some problems with that. The tools are software packages. The software packages have a language, a scripting language. Sometimes it's a standard language like Visual Basic. Other times it's a specific one for a particular tool. And the skills of a tester are different to the skills of a developer. If you want to, another factor is if you spend time with the tools, by the way, as a tester, you're not doing testing then. So getting tools in will set your testing back. You will do less testing by getting, so if you're under deadline pressure and things are getting late, and your boss says, oh, get a test execution tool in, that will guarantee you'll miss your deadline. Because it'll make you'll stop doing the testing and you won't get the tool up and running until after your deadline has long gone. So is it the tester's job to automate the tests? Test execution is a form of software development. It does need programming skills. Now, not all testers want to be developers. Maybe that's why they got into testing in the first place, because they like testing better than development, or would be good at it. Hans Buwalda says, if you make your testers become automators, you may lose a good tester and gain a poor programmer. Now, do the test automators, by that I mean the people who are working directly with the tool, the testware architect, the people who make sure that all the automated tests are working well so that the testers can feed tests into the automation regime, do they need to know about testing? I don't think it's absolutely necessary, although it is certainly helpful. But if the tester and the automator, they're two separate roles. They don't necessarily have to be the same person. They don't necessarily have to be two different people. It could be the same person who is both a tester and an automator. But if you have someone who is doing both roles, you have a conflict of interest. You come into work in the morning and you say, I'm going to be a tester today. And you run lots of manual tests. You run about 20 tests. And at the end of the day, you say, I did a good job today. I ran 20 tests. I'm a good tester. Oh, but I didn't get any automation done. Okay. Next day, you come into work and you say, right, I'm going to automate tests today. And you automate 5 tests. And at the end of the day, you say, I did a good job today. Those 5 tests now can be run overnight at the weekend. I've made sure they're sort of watertight and robust so that unexpected events don't derail them. They're good automated tests. But I only did 5 tests today. Now, you know what I mean by deadline pressure? Supposing there's a certain number of tests that have to get run before your system can be released. Is your boss going to say to you, well, the automation is more important, so You carry on doing 5 tests a day and we'll just push the deadline back. Is that going to happen? I think not. Even if automation is better long-term, deadline pressure pushes people back into doing manual testing because we have to get this product out the door. And so if the automation now is not being done, and then the managers are saying, oh, this automation isn't much good, is it? People haven't done much work on it. Let's scrap the whole lot. This is what happens. Now, I'm going to get on my hobby horse now. At the Eurostar conference last year, it was, what was his name? The guy who gave the keynote, he works with Selenium development. His name's gone out of my head. But anyway, he said, testers, if you want to have a future, learn to write code. And I vigorously objected, but most people were saying, oh yeah, okay, yeah, write code. Now, how many of you here would call yourselves testers? Do you write code? How many of you write code? Not all. Interesting. Now, do you want to have a future? This implies that people who do only testing, if they don't write code, they're now worthless, right? The only good tester is a developer tester. Anybody remember Vista? That was fully automated testing. They dispensed with having any human testers. All their testers were developers, right? Vista is why I went to Apple Macintosh. But that's another story. But if you're saying the only good tester, let me tell you about 2 people, okay? Tim and Jim. Tim has a degree in computer science. He's working in an agile team. He's doing testing and he's doing test automation. He likes to write code. He's quite happy to be a tester developer. And let me tell you about Jim. Jim has a business background. He worked in a bank. He worked in the branch office first. He was one of these people who, when the new computer system came, he would look at it rather than being frightened of it. And he would say, oh, I don't think this is quite right. So he got a reputation at being good at giving feedback to the developers from a user's point of view. He gradually drifted more into the IT side as a user representative, as a user acceptance tester. He doesn't want to write code. He's code phobic. Now, are you saying, okay, Jim, your days are over as a tester? If you do that, you will lose an awful lot of really good testers. One lady I talked to said that her high-level manager had said, right, all testers have to learn to code. Within a month, half of the team had left. All of the best testers had left. Well, maybe not all of them, but quite a few of them. So I think this is wrong. Users, and it's not all testers should learn to write code. I have no objections to testers who want to become developers. That's fine if that's what you want to do. And there is certainly a role for the tester developer, particularly in agile teams. But not everybody. Okay, only for those who want to. Because I think this is devaluing the skill of testing. And it's setting us back 20 or 30 years in the testing world. So I don't think it's right to be forcing good testers out of our industry just because somebody thinks they should be able to write code. Okay, I'll get off my high horse at this point. Oh, by the way, at the Star West conference, it was interesting that 2 of the keynotes, Melinda Tondi, who gave a lightning keynote, said, I think the pendulum has swung too far. And then Jonathan Bach, the brother of James Bach, he said, oh, I've been in testing for 13 years and I don't write code. So maybe things are swinging back. I hope so. So we've looked at a number of intelligent mistakes. Why are these intelligent mistakes? Well, because they seem very sensible when you first look at them. Automation should find bugs, tests find bugs, so automated tests are still tests. Well, that's true, but automation comes out of a box. You think you're buying a solution, but you're actually buying a box. Automate all manual tests. That's a good starting point for automation. ROI, you can't expect investment without showing some return. And testing tools are tools for testers. Well, they do run tests. But these are intelligent mistakes. It's not automation that finds bugs, it's tests that find bugs. Automation doesn't come out of a box. A tool comes out of a box. In order to be successful with test automation, you need to pay attention to your testware architecture and get that right. And it takes effort and time. you shouldn't automate all your manual tests. There will be some that should keep as manual tests. Do these colors look nice? Is this the way the users will actually work? You can't automate things like that. And you should also not only automate tests that are currently manual, but think about other tests that you can do easily with automation that you couldn't do easily with manual. And return on investment may be dangerous, but it is important to show benefits. And testing tools are tools for testers. Well, it's different skills, and not all testers want to become developers. So many of these ideas do seem sensible on first seeing them, but there's a sting in the tail. So I hope that you will recognize these intelligent mistakes if they're being made in your organization and be able to respond to them. And shameless commercial plug here for our new book, Experiences of Test Automation. There's my website. You can download stuff. I have a list of execution and framework tools. I will send you the ROI calculator if you really want it. One thing that I'm working on now is with Shweta Gamba, who contributed to this book. When she read the rest of the book, she said it jumped out at her, patterns. She's a developer. And so she wrote a book on test automation patterns. And first she asked me to be involved. And first I said, I've just done a book. I think I want to rest. But then a bit later on she said, well, would you review it? And when I read it, I thought, wow, this is fantastic stuff. So what we've now done is, rather than have it as a book, we've made a wiki. It works much better that way because the patterns and the issues that they solve are very closely interconnected. At the moment, it's an invitation-only wiki, just so that we can keep control of it while it's new. It might be made public later on. And if you'd like to have a look at that, I'd be happy to send you an invitation. And I think that's it. Thank you very much.
Hello. Thanks, Scott. Well, there's time for questions. So, has anyone got a question? No questions? I've got a question. Well, because you said that when you're buying a tool, it's going to cost you money to do the automation initially. So it's quite an expensive move then to buy in a tool. So at which point do you think you should try and persuade your organization that it's time to do that?
It's difficult. The consultant's answer applies here. It depends. Most organizations leave it too late, though. Mm-hmm. It's better to try and think about it as early as possible so that you can plan to have the tool there. But I mean, if you only have a very small system or you're not very far along, the automation may seem to incur a lot of costs but not give you a lot of benefits. It takes time for the benefits to build up.
Okay. And so typically, how long do people need to wait for those benefits to start to kick in?
If you've got a tool, if you haven't done automation before, if you're getting a tool in or experimenting with automation for the first time. By the way, if you're going to experiment, open source tools are great for that. But get more than one and see how they differ and see what works for you. And do maybe a 3-month pilot project where you automate some real tests and see if you can get some real benefit. Experiment with different ways of organizing your tests, whether you're going to do data-driven or keyword-driven or scripted tests and so on.
Okay. Okay. Any more? Sorry.
You have to have the microphone.
Sorry. Oh, yeah. Sorry. Just carrying on to a similar point, really. That diagram you did with the 3 sort of abstraction layers, what do you expect the test tool to actually do? Because
well, the test, seems, yeah, in that diagram,
how much of the test tool goes into the architecture part of the testing? Because for me, I think it's really hard to decide on the test tool and whether you even need to use one as well.
Right. The test tool in that diagram is just the bottom level. That's the tool that you buy. Everything else that you build above it is your tests. And your tests are organized in such a way that you can run those tests using that tool. So, for example, if the tool expects a script to be in a particular folder, for example, and you want to keep your scripts in a different structure, what you can do is just have as part of your pre-processing for the test, copy the script to where the tool expects to find it, and at the end of the test, copy the results to where you want to save it. So you separate as much as possible from the actual tool. You will have some scripts which obviously are written in the language of the tool, or you might write them yourself. You might write them in Perl or Ruby or something like that. And that can work well as well. Okay, so but you want to be able to use more than one tool. So you want to keep that interface as
And the tool
similar to an
itself
API.
doesn't really get involved in the actual automation.
Well, the automation engine is the tool that's actually going to execute the tests. The testware, that's all the testware are things like the scripts, the data, the input values, the expected outputs, and so on. And they all have to live somewhere. And that architecture is how are you going to design that so that everything has somewhere to live.
Thank you. We have a question at the back.
Hi, Dot. It's Peter Williams. If I came here as a senior manager and a budget holder, and I'd never had any experience of using automation tools, I would be thinking, why should we bother? So I've used tools and they've worked well in some cases, they've not worked well in others. So how does someone else go to sell or get the budget to go ahead and do this work?
Yes, I suppose I'm concentrating more on trying to disillusion people who have unrealistic expectations. So I'm not working in this talk on selling the benefits of automation, but the benefits of automation are myriad. I mean, things like being able to run tests that used to take you 2 weeks in 2 days or even half a day, being able to run being 2,400 times more efficient, which is what one of the case studies did. Again, at the risk of plugging my book again, it's got lots of stories in there about people who've achieved really good benefits with automation.
Okay, yeah, that answers the question, because I've experienced similar benefits in some cases, but
Right.
again, not others. So, thank you.
We've actually got a case study on our standards where automation helps a lot with
I'll go to the stand then and talk to Mike about it.
Yeah. Also, just a plug for, I know the people have heard of the British Computer Society Special Interest Group in Software Testing. It's a big mouthful, BCS SIGIST, which I helped put the conferences together for that. The one in December is where Dot will debate whether all testers should be coded. I think that's what it is.
Yeah, that's one of the things.
One of the things.
I'm also doing this talk again, and I'm also doing a workshop with the test automation patterns.
So if you're interested in that, that's British Computer Society, Special Interest Group in Software Testing, or BCS SIGIST for short. Okay, it's time to move on. So it's just thank you very much for Dot for a very interesting talk. Thank you.